Hello guys, in this video I am going to tell you what is material acceleration of steady velocity field. We are taking for the steady velocity field. We are finding the material acceleration of steady velocity field. The question is here, material acceleration of steady velocity field. Okay, in this steady, given that steady incompressible two-dimensional velocity field is given by vector field u comma v is equals to 0.5 plus 0.8x I cap plus 1.5 minus 0.8y j cap. So now this is an given velocity field, steady velocity field, and from this velocity field we have to find out the what is a material acceleration of steady velocity field. What is a material acceleration of steady velocity field? Now, where x and y are in meter and magnitude of velocity v is meter per second. So ax, we know that ax is equals to acceleration in x direction is equals to, we will take whole acceleration, so del u for the space coordinate on for the space and for time on for both, del t plus u, we are taking for the x, u is this one, u I vj. Okay, u du by dx plus v du by dy plus w du by dz. Okay, no problem guys. Now du by dt, here is no time coordinate, so it will become 0 plus u is 0.5 plus 0.8x into del u is what is u, 0.5 plus 0.8x whole upon my del x. Okay, and then plus v, what is v, v is 1.5 minus 0.8 y and du by dy, u is 0.5 plus 0.8 x, and there is no term for the w, so it become 0. So now you have to partial derivative of x with respect to x, here is an x, but in this we are derivating with respect to y, there is no, this is x, so there is no y term, so it becomes 0, no problem directly. For a constant, the constant derivative is always 0. For here and with respect, we are going to take derivative, partial derivative with respect to x, but there is no y term here, multiplying y coefficient, so will it also become 0. So now 0 plus, don't need to write, 0.5 plus 0.8x, the partial derivative of this u part with respect to x, the constant, for the constant it becomes 0 plus, for this it is 0.8, now it is become 0 and 0 it. Now multiply 0.5 plus 0.8x, 0.8 is equals to 0.4 plus 0.64x. This is the material acceleration of steady velocity field in x direction, and for y for acceleration in y direction is equals to del u by del v for y, del v by del t plus u del v by del x plus u v del v by del y plus w del v by del z. Okay, now in this again, no, there is no time derivation, time function here, so it becomes 0 directly. And in this case it is v means we know that what is v is in terms of y, only y coefficient in the v. So if you take a derivative of taking a derivative of y means it is, I will show you, u is 0.8 plus 0.8 plus 0.5 plus 0.8x into d by dx. b is 1.5 minus 0.8y. So you are taking a derivative with respect to x, but there is no coefficient of x, so it becomes 0 also, plus it is 0. Now v 1.5 minus 0.8y and taking derivative of dy, taking derivative of 1.5 minus 0.8y plus there is no term of in terms of w, so it becomes 0. So now it is 0, it is 0 already, and now it is only here. The derivative of this term with respect to y means the constant term, for the constant term it becomes 0, and for this it becomes 1.5 minus 0.8y into, it becomes 0 minus 0.8. Okay, this is the answer, 1.5 minus 0.8y into minus 0.8. So it becomes 1.2 minus plus is become minus 0.64y. The unit of acceleration is always meter per second square, and for this it is meter per second square. So thank you. If you like my video, please do subscribe my channel. Thank you all. You can see here, this is our ax and ay.